Okay, welcome to this video. We're starting a new chapter today. In this chapter, we're still going to talk about motion. So it's kind of a continuation, but we're going to learn a lot of different stuff, a lot of different things about motion in this chapter. So let's kind of talk about last chapter for a second. We talked about motion in terms of equations, right? We learned the equation for speed, velocity, acceleration. We also talked about diagramming motion with the oil drop diagrams, or the ticker tape diagrams, what you call them. In this chapter, though, we're going to take motion and explain it in terms of graphs. It's a little bit more complicated. We're going to go slow, and hopefully we'll make it easy for you guys to learn how to describe motion in terms of graphs. And we're going to look at some other things with motion too in this chapter, so stay with me. So we're hopefully, if you're watching the video, you're following along in your guided notes. So chapter 2 guided notes, please have that open. Okay, so let's get started. Okay, so, well, graphing motion. We're going to talk about graphing motion today. Motion can be graphed using the following graphs. Position versus time graphs. That's the graph that we're going to talk about today, is position versus time graphs. Next time we meet, we'll talk about velocity versus time graphs. So, I call position versus time graphs PT graphs. PT graphs. Okay, so as we go through the notes today, please follow along. We're going to go through a lot of practice problems. I'll go through a lot of examples before that even, and then we'll summarize it at the end. So hopefully by the end of this, we'll have a good grasp of what a position time graph shows us. Okay, a position time graph. On a position time graph, position data are plotted on the y-axis. So the position data are plotted on the y-axis, and the time data is plotted on the x-axis. If you remember back from our Introduction to Physics chapter, we talked about graphs and the y and the x-axis and which one's plotted where. So if you look at this graph down here, on the y-axis is position. Position is usually measured in meters. It's the SI base unit for length. On the x-axis, we're measuring time. And our units are what? Seconds. Now, if you take the ACT for the science, it's all graphs, isn't it, guys? One of the best things you can do when you're taking that is to look at your axes first, what they're labeled. So it tells you what they're labeled. And then when you look at the graph, you can kind of get an idea about what it's talking about. So always look at the axes first. Okay, so we've got position on the y. This is our dependent variable. The dependent variable always goes on the y-axis. Our independent variable, one that doesn't change or is not dependent, goes on the x-axis. So see how position is dependent on what time you're talking about? So position is your dependent variable. Anyway, so all they've done is take this data table here, and they made a graph from it. So for example, time is here. At time 0, it was at position 0. So you make a mark. At time 1 second, he was at 0.5 meters away. So 1 second, you go up to 0.5 meters. Make a dot. And so they've done this, and this is what their position, this is what a position time graph is. It shows you position here and time on the x. And if you draw and connect the dots, you get the graph. Okay. So let's talk for a second about what a position time graph, so PT graph, shows us. If you were to look at the slope of this line, let's talk about slope, okay? You guys remember from your math class, how do you find the slope of a line?
X or y over x.
Okay, changing y over changing x, right? What's an easy way to remember that?
Right.
Good. I always remember it rise over run. But you're right, when it's changing y over changing x. Okay, it's rise over run. How much? Let's find the slope of this line. Slope is given the symbol m. What is m going to equal in this case? How much did we rise here? We're talking about this segment right here. How much did we rise? 0.5, so I'm going to put that on top. And 0.5 what? What's it measured in? Meters. Okay, and then we're going to put the run on the bottom. How much did we run in this first segment? 1 second. So what is our slope telling us? Yeah, that slope is 0.5 meters per second. Oops, I don't know what happened there. So our slope was 0.5 meters per second. What's meters per second telling us? It's telling the velocity, right? So this object, I don't know what it was moving for the first second 0.5 meters per second. That's its velocity. So slope, I want you to write this somewhere. On a PT graph, slope tells us what, guys? Put that in your books, in the margin, on top, somewhere. Write that note. In a position time graph, the slope tells us velocity. Okay. So let's talk about this. Did this object in this graph have what can you describe its motion? How do you describe its motion? Constant. Did it ever change, or was it always 0.5 meters per second? Did it change, or was it always that? It was always 0.5 meters per second. Now, which way was it going? It's a positive velocity, so it must have been going to the right or up. It was at vertical velocity. Okay, good job. We can tell a lot from a graph, though, so that's what we're going to look at today. Okay, let's look at this one. I know it's not in your guided notes, but look up here. If we're starting at time 0, let's divide this into 3 segments. So I'm going to talk about this segment as number 1, and then from there to, looks like there, we're going to call this segment number 2, and then finally segment 3. Okay. Again, the best place to start by reading a graph is your axes. Miles is on the y, minutes is on the x. Okay, Brittany, what's happening in the first segment here? How would you describe the motion of this object? It's what?
I don't know.
Yeah, it's moving. It's moving, right? That's what you're saying. It's moving. Which way is it moving, guys? Is it going right or left?
Right.
It's going right. How do you know that?
It's going right.
Slope tells us what, guys, on PT graphs? Velocity. Okay, what I always do, I want you to get in the habit of doing this, is holding your pencil on the line. Is that a positive slope?
Yes.
Yeah. It's going up and to the right. That's positive slope. So we're going to have a positive velocity. That means we're going to the right or either up. Okay? So we're going to the right. Is it constant velocity or is it accelerating?
It's constant.
Yeah, it's always constant, isn't it? This line doesn't change. It's got the same slope. It's got the same slope throughout. That means it's constant velocity to the right. For the first 2 minutes, it moved to the right at a constant velocity. Okay, now what if I asked you, what was its velocity? How would you find it?
1 mile.
Rise over run. How much did we rise? 2. So slope here is equal to 2 meters, or miles. How much did we run? 2 minutes. So what's our velocity? 1 mile per minute. Okay? That's for this first segment. Okay, now let's go to segment number 2. Rylan, what's happening here?
He stopped.
How do you know he stopped?
Because his miles are better.
Yeah, he's staying at 2 miles. What's another way of determining that he stopped? What's the slope of this line? Slope is 0. So his velocity here is 0 miles per minute. Okay, so he stopped. So number 2, he stopped. Okay, number 3, Jason. Explain to me the motion of this object in this segment. Okay, he's moving. He's moving, right? He's moving. Now, is it, what can you tell me about the slope? Is it positive or negative? It's positive. And slope tells us what? Velocity. So we got a positive velocity. So he's moving to the right. What if I asked you what his velocity actually was? Could you tell me? What's rise over run? How much did it rise here? It went from 2 to 4. So how much did it rise? 2. And the units there are miles. And how much did it run? 2 minutes. Okay. So his velocity is equal to what? 1 mile per minute. Okay. Again, it's positive, so it's going up. So see how much information we can get out of a graph. It's incredible. By the time we get done with this stuff, I'm going to show you a graph, and you're going to describe its motion. You can even calculate its motion using the equations that we learned last time as well. Okay, good job. Okay, let's go to this graph real fast. It wasn't labeled correctly. It's not supposed to be. It's supposed to be minutes down here. Okay, so again, I'm going to call this one 1, 2, and 3. What's happening in the first segment? Just out loud. What's happening here? Constant what? Constant velocity. It's positive. So which way is it going? To the right. So he's moving to the right. What would it be? Rise over run is what? 1 mile per minute. Okay. So he's going to the right. He's moving constant velocity at 1 mile per minute. What's happening in number 2 again? He's at rest. His velocity then is what? 0. Slope there. Slope of that line is 0. Okay. Now let's go to 3. Now what's happening? This is a little different. What did he do? Let's talk about it.
Turned around.
How do you know he turned around? You're right. How do you know he turned around?
Because it's going back to the base point.
Yeah, because he went from 2 miles back to his original position, right? So he turned around right here, and he went back to his original position. Now, is slope positive or negative for this third segment? It's negative. Okay, so let's find his velocity is negative, so that means he went left.
Negative.
Let's actually find his velocity here. What was the rise here? In this case, it was a fall.
-2.
-2. So keep the sign. So slope, -2 miles. How far did it run?
+2.
+2 minutes. So velocity is a -1 mile per minute. So he went out to the right, then he stopped, then he came back. What if I asked you his displacement?
0.
Yeah, his displacement would be 0, because why?
Because it goes back to
Came back to the same spot he started from. Good job. Okay, so position time graphs. We're going to explain a lot in the next few slides. Please stay with me on the guided notes. So, is this on the guided notes, this one here? No. Okay, so just watch up here for a second. Consider a car moving to the right, so it's going right, at a constant speed of 10 meters per second. So we see it's constant. Every second he's 10 meters farther away. So it's constant velocity. The position time graph would look like what, guys? Well, it would look like this. Okay, you're starting at 0, 0. Every second you move 10 meters. So by the time you graph that, it's going to be a straight line. What can you say about the slope here, though? Positive or negative?
Positive.
Positive. Okay, so we're going right in physics. Right, it's positive. So positive velocity. Okay, now consider a car moving to the right and speeding up. It's not going at a constant speed. It's speeding up, which means it's accelerating. Notice here, in the first second it moved 2 meters. In the next second, though, it moved 8 or 6 more meters farther. So it's accelerating, it's speeding up. Here's what a position time graph looks like for acceleration. Okay, so we're starting at 0, 0. He's kind of going slow at the beginning, so we start with a slow slope, or a shallow slope. And then as time goes on, the slope increases. The slope is increasing. And so it's a curved line. So I want you to write this on your note somewhere, on a PT graph. Let's review. So slope tells us what, guys? velocity. And I want you to write this. Curved equals what? A curved line tells you that the object is accelerating. So that's really what we're going to focus on for the rest of this video and the rest of this class period. In position time graphs, the slope tells us velocity, and a curved line represents the object's, or it tells us that the object is accelerating. Now here's a trick I would like to see you guys get in the habit of doing. Okay, put your pencil on the line. I know you can't see me on the video, but I'm holding the marker on this line, this red line that I've drawn. Right here, the slope is close to what, guys? The slope is close to 0, so it's going slow at the beginning. But as you go through time, what's happening to the slope of that line? It's increasing. So if this marker was the slope, you can see how it's getting more vertical at the end, right? That whatever it is, that car is going slow at the beginning, and then its velocity is increasing as time goes on. So increasing velocity means acceleration. So that's how you would show acceleration on the graph. Okay, on a position time graph, constant motion and changing motion are shown like this. So this is a constant velocity. Again, it's a straight line with a slope. It's got to have a slope. If we're accelerating though, so we have a positive velocity and changing velocity, so we're accelerating, we're going to see that line is now curved. Okay, practice problem number 1. So in your books you've got A and B. I want you to draw 2 position time graphs. So draw your little box for A and B. And I want you to see, I want you to practice this. See if you can do it. On A, do constant positive velocity. And then on B, do positive velocity and positive acceleration. See if you can get that. So we draw our box. Let's label it. This is position on the y-axis and time. It's on the x. I'm going to do A first. Constant positive velocity. So positive velocity, is my slope going to be positive or negative? Positive. I better have a positive slope. And it's constant. So a constant positive slope, something like that. Okay. Now let's do B. A positive velocity and positive acceleration. So is there going to be a slope, guys? Yeah, there's going to be a slope. Is it going to be positive or negative? Positive velocity, so we have positive slope. But it also says we have acceleration. Positive acceleration. So how do we show that? A curved line. So it looks something like this. So it's got to be a curved line. On position versus time graph, the slope of the line is the object's velocity. Slope equals velocity. We just got to remember that. Okay. Positive slope is positive velocity. So which way would we be going if there's a positive slope? Which way? We're going to the right because in physics, right is positive. Or we could be going up if we're talking about vertical motion. But most of the time when we're describing motion, we're talking about motion left and right. But it could be up and down too if you're talking about a space shuttle or something like that. Okay, a negative slope tells us negative velocity. Which way would it be going? Left or what, guys? Or down. Okay, so I've got a few examples. This position time graph shows a slow, rightward, constant velocity. So how would you describe the slope here? It's pretty shallow, right? That's how you show that the object is moving slow. The slope is very small. Okay, if we're talking about something that's moving fast and going to the right at constant velocity, we're going to have a steeper slope. It's going fast. Again, it's still positive slope, so it's going to the right. But see how this one's a little steeper? The slope is greater, so it's going faster. Okay, if you wanted to show a slow, leftward constant velocity, we're going to start up here because we've got to have a negative slope because the it's going left. It's going to have a negative slope. So we got to start up here somewhere and just kind of a shallow line because it's going slow. Now what if we wanted to go left but faster with constant velocity? Again, we start up here because we got to have negative velocity, negative slope. But this one, it's steeped. It's a lot steeper. The slope is greater. It's going faster. Okay. To show that an object is moving to the right in a positive direction, we have a positive slope. That one's going to the right because it has a positive slope. To show that an object is moving left with a negative velocity, we've got to have a negative slope. Okay, practice problem number 2. There's 4 parts to it here, A, B, C, and D. I want you to see if you can do these on your own first. So if you're watching the video, hit pause and draw your position time graphs for A, B, C, and D. For the sake of space, I'm just going to draw one. But we'll see if you guys match up with mine. So part A, it says slow. So we're going slow. Rightward, constant velocity. So a lot going on there. So slow tells us, is the slope going to be steep or shallow? Shallow. It's going to the right, so what does that tell us? Positive velocity. So is slope going to go up or down? Slope is positive, so it's going up. And it's constant. Is there going to be a curved line or a straight line? Straight line. So let's see if we can do our best at drawing that. Okay, I'm going to label this one A. It's not that steep. It's going slow, but it's going to the right. That's how I would draw. Okay, let's do B. This one's going fast. And it's going to the right at constant velocity again. So the only thing that's different is that B is going faster. How do we show that? We better have a steeper slope, a greater slope. So that's B. Notice that its slope is greater than A. Okay, part C, it's going slow, but this time it's going left at a constant velocity. So it's going to have a shallow slope, but is the slope going to be positive or negative? Negative. So I've got to start up here somewhere and just kind of come down kind of shallow. Straight lines, not curved. And I'm going to label that one C. Okay. Now D, the only difference is that this one's going fast. It's still going to the left and it's still going at constant velocity. How do we show it's going a little faster? Steeper slope. I call that one D. How many of you guys got those? Okay, good job. Good job. Let's talk about acceleration in a little more detail. Acceleration on a position time graph. So on a position time graph, acceleration is shown with a curved line. So whenever you see a curved line, you know it's accelerating. Now, can acceleration be positive and negative? Yes. So let's pay attention to what that means. Acceleration can either be positive or negative. And remember, we talked about this last chapter. But if the object is slowing down, so if you hit the brakes, then the acceleration is in the opposite direction of its motion. So if you're going to the right, but you slow down, which way, so your velocity is to the right, but you slow down, which way would your acceleration vector be pointing?
Left.
Yeah, your acceleration would be going to the left. Now, what if you were going to the left with your velocity, but you slow down? Then your acceleration is to the right. So just remember, if you ever hit the brakes or you ever slow down, your acceleration vector switches. Okay, here's how you would show negative acceleration. Well, a negative velocity and a negative acceleration. So we have negative velocity. That means our slope is going to be what? It's going to be negative, so we've got to go down. And if we want to have a negative acceleration, we've got to speed up. So here's how you would show that. We got a curved line starting real slow, and then over time, that slope gets greater. So let's hold our pencil on this. What's the velocity right here at the beginning? Fast or slow? Slow. What can you say about the velocity over time? Speeds up. So we're going to the left. So our velocity is to the left, but we're speeding up. So which way would our acceleration be? Does it switch if you speed up? No. Acceleration is also to the left, which is negative. Okay. So that's negative acceleration going to the left and speeding up. That's how you would show it. Okay, now how would we show positive acceleration with a leftward velocity? So we're going left still, but now we're going from fast to slow. So if you show fast to slow, you're starting here with a steep slope, and then over time it kind of shallows out. So if you put your pencil on this line, at the beginning the slope is very steep. We're going fast. As time goes on, what happens to your velocity? It's going closer to zero, right? It's slowing down. So we're going left in this situation, but if we slow down, what way would our acceleration vector point?
Right.
To the right. And so that's positive acceleration with a leftward velocity, or negative velocity. It's a little tricky there. We just got to kind of think about it. Practice problem number 3. It says below, draw a position time graph for the following situations. Again, you got 2 parts. You got A and B. So if you're watching the video, take a second, pause it, see if you can draw those 2 position time graphs. Okay. For A, it says negative acceleration, moving in the negative direction and speeding up. So, negative direction. How do we show negative direction, guys? What's our velocity going to be? Well, it's going to be negative. Negative velocity means negative slope. So we're going to start up here and we're going to end down lower. Now, it's speeding up. How do we show speeding up? Got to think about this. How do we show speeding up? Yeah. Well, okay. So think about the slope at the beginning. Is there going to be much slope at the beginning? No, because we're going kind of slow, and then we're speeding up. So then the slope gets more dramatic. If you hold your pencil on that at the beginning here, the velocity is almost zero. You're almost stopped. You're going slow. And then as time goes on, the velocity gets more, or the slope gets more steep, so your velocity gets greater. So that is A. I would call this one A. Now let's do B. A positive acceleration, moving in the negative direction though, and slowing down. So again, are we going to have a positive or negative slope? We're moving in the negative direction, so it's going to have a negative velocity, and we're slowing down. Okay. So again, we've got to have negative slope. We're going to start here, but now we're going to kind of shallow out. So we're going fast. If you hold your pencil on that, the velocity is the slope is very steep here, so it's very fast. And then as time goes on, what happens to velocity? It slows down. And so that's how I would draw the position time graph for part A and B. How many of you guys got that one right? That was a tough one. It takes some thinking about it. What I think is the most important thing that you guys can do is practice asking yourself, what's the velocity at these different points? Hold your pen up there and look at the slope. The slope tells you velocity, so it's going, and you can see what it's doing. Okay, practice problem number 4. It says, draw a position time graph in each of the following scenarios. So you got A, B, C, D, and E here. So if you're watching the video, hit pause, take a second and answer those. For you guys in the classroom here, same thing. Take a second and see if you can do that. I'm going to solve it on the board, but don't look up here until you're done. Okay. Okay, so after you're done, look up here and see if your position time graphs. I did it all in the same one because I didn't have enough space. See if your position time graph looks like mine. Let's go through it. On A, the object's not moving. So I drew it up here. Just got to make sure that your slope is 0, right? Could have I drawn it down here?
Yeah.
Or up here?
Yeah.
It anywhere you want to draw it, but you just got to remember, for not moving, your slope is equal to 0 because your velocity is 0. Okay, let's go to B. The object is moving with constant positive velocity. I just drew positive velocity tells us the slope is positive. So a constant is a straight line. It's not accelerating, so there's no curve. Part C. The object is moving with a constant negative velocity. So constant tells us that it's a straight line, but negative velocity tells us the slope is negative. So you'll notice on C, I started up here and then came down in a straight line, negative slope. Okay. Part D and E is where it got a little bit more complicated. So D says the object is moving with a positive velocity and has a negative acceleration. Now, positive velocity, we're going to the right, but how can you have negative acceleration moving to the right? How do you have negative acceleration moving to the right, guys? You got to slow down. So on D, you'll notice I started pretty steep slope because our velocity is pretty fast. Then as time went on, you'll notice that the slope at the end was almost 0. So we're slowing down. We have a positive slope that tells us positive velocity, but when we slow down, that flips your acceleration the other way. So that's how we have negative acceleration. Okay, let's go to part E. The object is moving with positive velocity and has a positive acceleration. So again, positive velocity, we're going to the right with our velocity vector. And a positive acceleration, which way is it going? Also to the right. So how do we show that? It's got to be speeding up, going to the right. So on D, you'll notice that the slope at the beginning is very shallow. It's almost going no slope here. But then as time goes on part E, as time goes on, you'll notice that the slope gets steeper and steeper. So he's speeding up. Slope's positive, is going to the right and speeding up. Okay, I want you to take a second. Let's do this. It says use graph paper, but I don't have graph paper. So take out a piece of scratch paper. Take out a piece of scratch paper. And I want you to make a position time graph from this data. If you're watching the video, I want you to do this. So take out a piece of scratch paper. Make a position time graph based off of this data. Be careful here. Position is labeled first. So this column right here is your position. And this column here is your time. So if you want to, pause the video and then hit play once you've got it made. Okay, so for you guys that are here in the classroom, here's how I would do it. You've got your axes here. We've got position on the Y. And we've got time on your X. Let's also put the units. The units for time is seconds, and the units for position were meters. Now, when you're making a graph, it's a good idea to look at the greatest, like your range here. We're going from position of 0 to, what's the greatest position we get to? 2. So when we make our graph, obviously this is going to be 0, the bottom. Now, if we only go to 2, let's space it out a little bit. Let's go, this is 1. And let's keep it equal distance apart and say this is 2. Okay, let's do the same thing for time. What's the range here? What's the greatest number of time? 10. Okay, so we've got to make 10 marks here. Try to keep them equal distance apart. Okay, and so there's our starting point. Now let's just plot them. What you do is you go at time 0, we were at 0 meters. So we make our mark. 0 and 0. Okay, at 1 second, we were at 1 meter. Okay, so 1 second at 1 meter, make a mark. At 2 seconds, we're at 2 meters. At 3 seconds, we're still at 2 meters. At 4 seconds, still at 2 meters. 5 seconds, still at 2 meters. 6 seconds, 2 meters. 7 seconds, 2 meters. 8 seconds, still at 2 meters. Okay, now at 9 seconds, we go to 1 meter. So we're coming back down to 1 meter here. And at 10 seconds, it looks like we were back at 0 meters. Okay, so once you have all of them plotted, now let's do our best at connecting the dots with a line of best fit. So look at it, try to make the best possible line through those marks. Okay, you should get something that looks like that. Now, let me ask you some questions about this position time graph. Just looking at that, you're going to get to the point where you're going to be able to know exactly what that object did. Okay? Let's say this object is a car, a toy car on the counter. What is it doing for the first 2 seconds, that toy car?
Moving.
It's moving which way?
Right.
To the right. How do we know it's moving to the right? It's got a positive slope here. So that car must be going to the right. Now, describe its motion. Is it accelerating? Is it going at constant speed?
It goes at a constant speed.
Constant speed. Now, what if I asked you to calculate or tell me its velocity?
Stops, bro.
It's 1 meter per second.
Yeah, we can. Remember, slope is equal to velocity. How do we find the velocity? It's rise. How much did it rise?
To 2.
To what? Meters is the unit. How much did it run in the first 2 seconds?
2 seconds.
2 seconds. So what's its velocity here? 1 meter per second. So it's going 1 meter per second to the right for the first 2 seconds. Now from 2 seconds all the way over, it looks like, to 8 seconds, how would you describe its motion?
Stop.
So that car did what? It stopped.
Instant.
Okay? Instantly. So velocity here is 0 meters per second. Rise over run, it didn't rise any. It did run 6 seconds, but 0 divided by 6 is still 0. So your velocity is 0. Here's what stopped. Now, what's happening from 8 to 10 seconds? How do you know it's going to the left? Because it's a negative slope, and the slope tells us velocity, so it's got to have a negative velocity. What if I asked you to calculate its velocity right there? How would you do it? Well, rise over run. In this case, it didn't rise, it fell. How much did it fall? Minus 2 meters. How much did it run? 2 seconds. So what's my velocity? Minus 1 meter per second. Some cool things we can get out of a graph, right? If we learn how to read it correctly. So that car went to the right, stopped for 6 seconds, and then it came back to which point? To its original point that it left at, point 0, right? So it went to the right, stopped, and then came back to the left at its original point. Okay, very good. Okay, this was just breaking down what we just did. To find slope, we do rise over run on that graph. Slope, if you look at it, is change in displacement over change in time. Another way of saying that is displacement final minus displacement initial over time final minus time initial. Guys, this is the equation for what? Velocity. We talked about that last chapter. That's all we're doing to find slope, is that equation right there. Okay, we used the graph. We found the velocity from 1 to 2 seconds. That was 1 meter per second. Okay, we also did the velocity from 2 to 8 seconds. We found that was 0 meters per second. And then from 8 to 10 seconds
Negative.
is a minus 1 meter per second. So yeah, we did get all the answers correct. So good job. Okay, let's summarize what we've learned. Okay. The summary of a position versus time graphs. It says a positive slope indicates positive velocity. So positive slope indicates positive velocity. And how would you describe that motion? Which way? To the right or up. In physics, to the right is positive. Okay, a negative slope, on the other hand, so negative slope indicates what? Negative velocity, and motion is to the left or down. It's because in physics, left is negative, and so is down. Okay, we also talked about how a horizontal line indicates zero velocity. So a horizontal line, slope is zero velocity. And the position remains unchanged, you're at rest. Okay, we also talked about acceleration is indicated by a curved line. So whenever you see a curved line, you know that the object is accelerating or decelerating. Okay, and then finally, if the object is slowing down, so you hit the brakes, the acceleration vector is in the opposite direction of its motion. So when you hit the brakes, the acceleration vector is in the opposite direction of its motion. Okay, so a couple of things, and I want you to write this at the top of your page. For position time graphs, so for PT graphs, some things you've got to remember from this video. Slope is equal to what, guys?
Velocity.
Slope tells you velocity. Okay, what does a curved line tell you? Good. If you can remember that, you're doing well. It takes some time to think about it. Okay, it does. It takes some time to think about these graphs and how to make them and what they mean. But hopefully this helps you understand position time graphs and how to make them, how to describe the motion that they show. So at this point, we're gonna stop this video. You guys have learned enough to do a worksheet in the student workbook. The worksheet that you should do now is called position versus time graphs. So turn your books there, position versus time graphs, and try that. Hopefully this helped.